perpetuities. So this is the chapter outline. We're going to consider these two types of cash flow streams. Perpetuities are cash flows that are constant and last forever. Annuities are also cash flows that are constant or the same every period, but have a finite maturity. In other words, they last a certain length of time. So let's specifically look at perpetuities. And in the timeline, you can see the infinite set of equal payments here. The payments are C, and they occur at the end of the first period for a perpetuity. And it goes on forever. So you see that there is no ending period. How do we value a perpetuity? The present value of the cash flow in perpetuity is that cash flow that is constant divided by the interest rate. Valuing perpetuities are easy, and we like valuing them because they are so easy. So you just take the cash flow and divide by the interest rate, the discount rate, the cost of capital, which are all the same thing. It is the interest rate that we are discounting those cash flows by. The present value of an annuity of C cash flows for n periods with interest rate R is the cash flow times 1 divided by R times 1 minus 1 divided by 1 plus R to the nth power. This is equation 4-5. Remember that this is the present value of an annuity formula. Remember, the present value of a perpetuity was simply the cash flow divided by R. Now that we have number of time periods, we have a different equation. What is the future value of an annuity? This is another big, hairy formula. You're mostly going to be using your financial calculator when you compute annuities. However, it's important to understand and to know the formula. And it's right here, equation 4-6. And simplified, it's C times 1 over R times 1 plus R to the n minus 1. Rearranging the present value of an annuity gives you the future value of an annuity. One final thing. What is the difference between an ordinary annuity and an annuity due? We've been dealing with both of them in this chapter and we're in this video, and we're going to be dealing with both of them in this chapter in class. You're going to see them in My Finance Lab. An ordinary annuity, the payments come at the end of the period. So it is the first timeline that says ordinary annuity. The payment occurs at the end of period 1, at the end of period 2, and at the end of period 3. An annuity due is a cash flow pattern where the annuity payments come at the beginning of the period, just like what we did for the first one. But then it was 7 years, so we could treat it like an ordinary annuity for the next 6 years. So when the payments come at the beginning of the period, we can see that this is still a 3-year, both of them are 3-year annuities, but the payments come at the end of period 1 and 2. That's the equivalent. So to value the annuity due, we could have taken and valued the present value of an ordinary annuity at the end of years 1 and 2, and added the payment at time period 0 to it, and that would have been equivalent to valuing an annuity due. Which is more valuable? An annuity due is more valuable because if the cash flows come sooner in time, and sooner in time means a higher value for present value as well as future value. We're going to talk more about how you compute annuity dues if you want to just keep the annuity payment as one payment and make the changes in your calculator. You would switch from end to begin mode. This is also covered in the calculator section on ELMS. See you in a little bit in video 3.